All right, so now we're going to start applying our calculus tools, the idea of limits, which we talked about last semester, and how that can be applied to areas of irregular shapes. Okay, so what we have here is this region. It is the area under this curve. Okay, so we have this parabola, okay, and hopefully you can see it here in red. Okay, so I have this parabola that's going down, and I want to find the area under that curve. Now, that's shaded in red, and we don't have any geometry formulas for finding this area because it's a parabola, it's a curve. So what we're going to do is we're going to split it into 5 rectangles. And we did one of these problems like way back in August. It's been a long time ago. Okay, so we've got these 5 rectangles split up, and we are going to find the area of these 5 rectangles and use it as an approximation. So our area is going to be the sum of rectangle 1 plus rectangle 2, rectangle 3, rectangle 4, and rectangle 5. Okay, so let's find the area of each of these. Now, it is from 0 to 2, and I've split it into 5 parts. So each of these rectangles is going to have a width of 2/5. Okay. All of them will. Okay. All of those are 2/5. So if we want to do this first rectangle, we'll call this rectangle 1. Okay. So it's length times width. So the length of it is 2/5. Okay. And then the height of this is going to be the y value here. Okay. So to find that y value, we will plug 2/5 into the function. Okay, so that's rectangle 1. Rectangle 2 is also 2/5. The height of that rectangle is when you plug in 4/5 into the function. So it'll be f of 4/5. Our next one is also 2/5. And the height of that rectangle is going to be when you plug in 6/5 into the function. The next rectangle is also 2/5. The height is going to be when you plug in 8/5 into the function. And the last rectangle, of course, is still 2/5. And the height is going to be when you plug in 10/5 or 2 into the function. Okay. So now we're actually going to do that, 2/5. This is the function right here. So when you plug in 2/5 into that, you can use your calculator for this. I think it's 4.84. Okay. And then we have 2/5. You're going to plug in 4/5 into this function. Again, use your calculator, 4.36. And then you're going to plug in 6/5 into this function, 3.56. And then you're going to plug in 8/5 into this function, 2.44. And finally, you're going to plug 2 into this function. And your last step is you are going to use all of those, multiply, add them together, and we get 6.48. So remember, that is the area of all 5 of these rectangles. Now, notice that we still have all of that red space here, 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 and here that didn't get counted. So we know that this estimate is too small, but it's still an estimate. It gives us a starting point. Now, another way we could do this is, let's go the other direction when we scroll, is we could draw our rectangles differently. Okay, notice on the one up here, I had the right-hand endpoint of all of those rectangles on the function. We could do it slightly differently with putting the left endpoint. Okay. Now, this time, do you see how all of our rectangles overhang the function? So our estimate this time is going to be too big, but it'll still give us kind of an upper bound for this. So Sorry about that scrolling. It's out of control. We have no idea what's going on. So we're going to do the same thing. We're going to find the area of these 5 rectangles. 1, 2, 3, 4, and 5. Just like before, I've gone from 0 to 2 and I've split it into 5 parts. So each of those rectangles is going to be 2/5. Okay, so that's going to be 2/5 right there. And then to find the height of this rectangle, now I have to use the left endpoint. So it's when I plug in 0 into the function. Okay, so that's going to give me the height of this rectangle. Now, my second rectangle is still 2/5. Okay, but the height of it is going to be when I plug in 2/5 into the function. My third rectangle is still 2/5. The height of it is right here at 4/5. So f of 4/5. My next rectangle is still 2/5. The height of it is when we plug in 6/5. And my last rectangle, this one, is still 2/5. And the height of it is when you plug in 8/5. Okay, so now we're actually going to do those. Okay, so to do f of 0, you're plugging 0 into this, which is going to give you 5. To find f of 2/5, you're plugging into this, which we already did that, 4.84. And then we're going to plug in 4/5 into the function, 4.36. And then we're going to plug in 6/5 into the function, which we already did all of these. We have these numbers above. And we're going to plug in 8/5 into the function, 2.44. Okay, use your calculator, multiply those, add them up, and we get 8.08. Now again, since we use these rectangles that overhang the function, this is too big, okay? But we know the actual area, still scrolling out of control. So sorry about that. The actual area is going to be somewhere in between these. This one was too small, this one's too big, but the actual area is going to be in between that. So in general, the inscribed rectangles is called the lower sum. That's the one that was too small. The sum of the areas of the circumscribed rectangles is the upper sum, and that's the one that's too big. Okay. Now, ideally, we would like a perfect one. And so the way to get better estimates is more rectangles. So we'll check that out in the next video.